Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon, my dear students, grade 12 students in your math session. The SAT course, and this is your matrix session. Inshallah, we'll talk about the matrix and the determinants. Matrix and the determinants, a very important part and always repeated in the exam. We have to talk about first the matrix, what is the matrix, and then the types of the matrix, how we can do the operations on the matrix, adding, subtracting, multiplying matrix, what is the equality of two matrix, and the determinants. We'll start by what is a matrix. The matrix is an arrangement. The matrix is an arrangement for the data, for some data in rows and columns. In rows and columns. So if you have a matrix, the matrix contains a set of data, which are arranged in rows and columns. In rows and columns. We denote the matrix by a capital letter. We denote a matrix by a capital letter. So if we have a matrix A, for example, if we have a matrix A, we write a capital letter A. Inside the matrix, we have elements, which are the numbers, which are the rows and the columns. We have a small letters. For example, if I said here, we have to write A, 1, 1, and then write A, 1, 2, and then write A, 1, 3. That means we have three elements in the first row. In the first row, we have, so the first number here, 1, 1, it means the first row and the first column. The first row is the second column, the first row and the third column. So if we go into the second row, we just write A, 2, 1, and then A, 2, 2, and then A, 2, 3. So we have here, this is the elements, or this is the arrangements. We have here, this is the rows. We have two rows and we have three columns. Two rows and three columns. So we have the order of the matrix. The order of the matrix. What is the order of the matrix? The order of the matrix is a product between the number of rows and the number of columns. A product between the number of rows and the number of columns. Start by the rows first. We have how many rows? 1, 2. So we have two rows. So we have two rows. So I just write 2 here. And then multiplied by the number of columns. We have how many columns? 1, 2, 3. So 3 columns. So we just write 3 columns. So I just write 3. So the order of this matrix, or the matrix row and column, we have here start with the row first and then the column. Okay, so 2 times 3. If you ask you about the row, it's 2 times 3. Okay, so the order of the matrix is starting by the rows and the columns. The order is very important, and any element in the matrix we can denote it by its position. For example, if I said A22, it means the second element in the matrix, in the rows and the columns. It means the element to stand in the second row and the second column. What about 2 and 3? The second row and the third column, and so on. The types of the matrix. We have some types of the matrix. We have zero matrix, or the elements of the matrix are zeros, or the elements of the matrix are zeros. And as you see, this matrix, its order is, yes, it's 2 multiplies 3. Okay. Identity matrix, or the elements of the matrix are 0 except the main diagonal. What are the main diagonals? The main diagonals are these diagonals. These diagonals are called main diagonal. So the diagonal which coming like this, it's called main diagonal. If we talk about identity matrix, square matrix, identity matrix, or a square matrix, okay, this matrix means the number of rows equal the number of columns. The number of rows equal the number of columns. Mister, we have here 2 rows and 2 columns. And also in the square matrix, we have 2 rows and 2 columns. Must be 2? No, of course. If you have 3 and 3. So 3 times 3, 4 times 4, 2 times 2. All these are called the square matrix. A special case from the square matrix, if you have the identity matrix. If we have 3 times 3, for example, So it's a square matrix, and it will be identity matrix if you have here 1, and you have here 1, and you have here 1, and the rest of the elements will be zeros. So all the elements are zero except the main diagonal elements, except the main diagonal elements. Okay. So this is a square matrix. Column matrix, it means the matrix that contains one column and any number of rows like this. We have two rows and one column. Row matrix is opposite. We have one row and any number of columns. So we have here one row and multiplied by 3. Yes, we have 3 columns. Okay, so this is the types of matrix. We have zero matrix, we have a square matrix. A special case from the square matrix is called the identity matrix. All the elements are zero except the main diagonal elements. We have the column matrix and the row matrix. Two equal matrix. The two matrices are said to be equal if the corresponding elements are equal. If the corresponding elements are equal, where if you have like this, so we have two matrices, and we need to get equality between them. So the equality is satisfied if and only if we have two matrices, the two matrices are equal, if and only if we have here A and here B and here C and here D. In the other matrix, you have X and here Y and here Z and here L. So these two matrices are equal if and only if A equal X, B equals to Y, C equals to Z, and D equals to L. So if you have this condition satisfied, so the two matrices are equal. So the two matrices are equal. Okay, so this is the equality between two matrices. Equality between two matrices. How we can add or subtract two matrices? How we can add or subtract two matrices? For example, if we have a matrix and this matrix contains, for example, 2, 3, 1, -1, 5, 4, and we need to add to the matrix which equal 2, 7, 1, 3, 8, 5. If we need to add first or subtract, you must check. How can I check? You make a test. You can add or not. You can subtract or not. To add or subtract the matrix, they must have the same order. They must have the same order. So they must have the same order. They must have the same order. For what? For adding and subtracting. So I'll check. The order of the first matrix is 2 rows and 3 columns. So 2 times 3. The order of the second matrix, Mr. It's the same. 2 times 3. So I can add or subtract. And the result will be the same order. So from the beginning, the result will be 2 times 3. Start to add. Add the corresponding elements. It means 2 plus 2. So 2 plus 2 equals to 4. 3 plus 7. So 3 plus 7 equals to 10. And 1 plus 1 equals to 2. We have here -1 plus 3 equals 2. 5 plus 8 equals to 13. 4 plus 5 equals to 9. We add. But if I said, for example, I have to add this two matrix. We have here 5, we have here -3, we have here 1, and we have here 0. And this matrix contains 7 and 2. So the order of the first matrix is 2 times 2, and the order of the second matrix is 2 times 1. We can't add, so it's impossible. Okay, so impossible to get addition between two matrices that have different order. Addition or subtraction, the same rule. How we can multiply a matrix with a constant? For example, if we have a matrix, this matrix is called A. So A is a matrix, and the matrix A contains 1, 2, 5, 7. And we need to get 3A. So, mister, we need to multiply this matrix by 3. So I just write 3 out and write the matrix 1, 2, 5, 7, and then multiply. multiply 3 by each element, multiply 3 by each element. So I multiply 3 by 1, multiply 3 by 2, multiply 3 by 5, multiply 3 by 7. So Mr. 3 times 1 equals to 3, 3 times 2 equals to 6, 3 times 5 equals to 15, and 3 times 7 equals to 21. So if we need to multiply a matrix by a constant, we just distribute this constant on the elements of the matrix by multiplying, of course. Even this number is negative or is positive. Mr. How we can multiply two matrix? Multiply two matrix. To multiply two matrix, to multiply two matrix. So matrix multiplication. Matrix multiplication. What is the multiplication for the matrix? To multiply two matrix, we must have an important condition that must be satisfied. They must be satisfied. So if we have a matrix A, which is its order is m times n, and multiplied by matrix B, which is its order will be n times L. How we can multiply? First, the condition or the rule says to multiply the matrix, the number of columns of the first matrix must be equal to the number of rows of the first matrix. Again, the number of columns of the first matrix, which is n, must be equal to the numbers of rows of the second matrix, which is n also. So they are equal, so we can multiply. So the number of columns of the first must be equal to the number of rows of the second. If this condition satisfied, we can complete. If this condition not satisfied, so we can't multiply the two matrix. Okay, so we have here to multiply. Yes, Mr. We can multiply. So you can multiply. So the result will be A times B or AB, A times B or AB, and the result will be of the order. What is the order of the first, the result from the beginning? The order of the result, the result will be the first number here. It means the number of rows of the first, which is M, multiplied by the number of columns of the second, which is L. So again, to multiply the middle or the mean numbers must be equal. Here N and here N, they are equal. So I can now multiply. And the result will be of order here M multiply L. M and L are multiplied together. This is a multiplication of matrix. This is a multiplication of matrix. We're going to the second order determinant. Second order determinant. The value of the determinant, which is second order, it means 2 times 2. 2 times 2. The determinant is how to calculate the value of the matrix. If you have a matrix and we change it into determinant to calculate the value of it. For example, if we have here A and here B and here C and here D, this is a determinant and called second degree determinant. Second degree determinant. Second degree determinant, it means determinant 2 times 2. Determinant coming from the matrix 2 times 2. How we can find its value? The matrix, if we need to find its value, change it into determinant by this value. The matrix to change into determinant, it must be a square matrix. It means it can be 2 times 2, 3 times 3, 4 times 4, and so on. Okay, how we can get the value of this? We just multiply the main diagonal. So I multiply A multiplied by D. So I just write AD minus. The rule contains a minus. The other diagonal, it means B times C. So B times C. So to get the value of the determinant that contains 2, 3, -1, and 5, it will be equals to 2 times 5 equals to 10 minus 3 times -1 equals -3. So it will be 10 minus -3, it means 30. Okay, so to get the determinant, you must get the answer like this. Pay attention with me. The matrix multiplicative inverse. The matrix multiplicative inverse. If I give you a matrix like this, if I give you the matrix like this, it's A, B, C, D. And I asked you to get the multiplicative inverse. You must check. To get the multiplicative inverse, we must check by getting the value of the determinant. If the value of the determinant for the matrix, if the value for the determinant of the matrix is equal to 0, so there is no multiplicative inverse. There is no multiplicative inverse. So the multiplicative inverse for the matrix, the multiplicative inverse for the matrix is satisfied or is in the matrix, satisfy the matrix if the matrix determinant is not equal to 0. If the matrix determinant is equal to 0, so no multiplicative inverse. How we can get the multiplicative inverse? To get the multiplicative inverse for a matrix, this matrix is called, for example, A, B, C, D. So A, B, C, D is a matrix. I need to get the multiplicative inverse for the matrix. So the matrix is called, for example, A. I need A power negative 1. It means that the multiplicative inverse for the matrix. First, I get the determinant of the matrix. I get the determinant of the matrix. So, Mr. It's 1 over the determinant for the matrix. So the determinant, we write it like this, absolute value like this. So this sign is called here in the matrix the determinant. So I get the determinant and write 1 over the determinant. 1 over the determinant. Multiply by the cofactor. What is the cofactor? The cofactor of the matrix, it means you will flip the main diagonal elements. Mr. The main diagonal elements are A and D. Flip them. So it will be D and A. And change the sign of the other diagonal. It will be Mr. negative B and negative C. So again, if we need to get a multiplicative inverse for a matrix, the first step, get the determinant. How can I get the determinant? I get the determinant by multiplying the main diagonal element by the other diagonal element. If we get a number except 0, we just write 1 over the result multiplied by the cofactor. What is the cofactor? It changes the main diagonal elements and it changes the sign of the other diagonal elements. Okay, this is what we have in the first lesson, which talking about the matrix. Let's go directly to the problems. Let's go directly to the problems with problem 1. Problem 1. Number 1 in the matrix, and he give me the matrix like this. What is the element 2 times 3 or 2, 3? Sorry, 3 times 2. 3 times 2, it means, Mr. We have in this matrix, what is the order of this matrix? The order of this matrix, Mr. We have 3 rows and 3 columns. So it's 3 multiplied by 3. Okay, so 3 multiplied by 3. I need to find the element which stand in the third row and the second column. The third row and the second column. So the third row, 1, 2, 3. And the second column, oh, it will be the second column. So the third row and the second column. So this is the element, which is 2. So the answer is 2. So the answer is 2. How, Mr.? The element in the third row, and second column. So it's 2. We're going to the second one. A and B are two matrices of dimensions 5 times 3. 5 times 3. So the order of A minus B. The order of A minus B. We said that if we need to add or subtract, the two matrices must have the same order. And the result will be with the same order also. It means if the matrix A with the order 5 times 3, and we make minus the matrix B with the same order 5 times 3, so we can perform the operation. And the result, which is A minus B, the order of the result will be also 5 times 3. Will be also 5 times 3. So the result will be 5 times 3. 5 times 3. We're going to number 3. In number 3, I have a matrix A, which is, yes, 2 times 2, excellent. And I have a matrix B, which is also 2 times 2. And I need to find 3A minus B. 3A minus B. It means you will multiply A by 3 and then subtract B. They have the same order? Yes, they have the same order. So I can add or subtract. I can subtract. There is no problem. But before subtract, you must multiply the first matrix A by 3. So the first step, I'll multiply by 3. We have the matrix A start by -1, becomes a -3. 0 is still 0 as it is. We have 2 becomes a 6 by multiplying by 3. 3 will be 9. After that, I just write minus and write the second matrix B. We have 0, we have -4, we have 1, and this is 5. Now get the result. How we can get the result? We get the result by this way. We have to add or subtract the corresponding elements. We have -3 minus 0 equals -3 as it is. 0 minus -4, 0 minus -4 minus negative change into positive, so it becomes a 4. We have 6 minus 1 equals to 5, and 9 minus 5 equals to 4, and this is our answer. This is our answer. So -3 and 4, 5 and 4. -3 and 4, 5 and 4, which is letter C. Which is letter C. Okay, so if you have a problem like this, it's a very, very easy problem. Just multiply, and then after that, by the constant, or by the value of the constant, and then after that, add or subtract according to the requirement. We're going to the fourth problem. We're going to problem number 4. Problem number 4, if the dimension of matrix AB is 5 times A. So if you get the product, it means A multiplied by B, we get the result as 5 times 8. And the first matrix, which is matrix A, is 5 times 6. Then I need the order of the second matrix. So pay attention with me, please. So A, he gave me the order of A is 5 times 6. And I need to get the order for the matrix B. The order for the matrix B. So I have here two numbers multiplied together. We need to answer. We said that to multiply or to perform the multiplication operation for two matrices, you must get the same number inside, or the mean numbers will be the same, like this. So this number is 6, so this number also must be 6. This number also must be 6 to perform the operation. So the first, we have to get the number of the rows of the required matrix as 6. Why, mister? Because the number of the rows must be equal. The number of the rows must be equal to perform the multiplication operation. And then we set the result, or the product or the result will be, yes, from the number of rows of the first and number of columns of the second. The number of rows of the first is 5, and we wrote here 5. And what about here? Yes, it's 8, so I just write here 8. So we have here B is consists of 6 multiplied by 8. So the order of the matrix B will be 6 times 8. 6 times 8. Of course, the order is very important. If you write 8 times 6, it's wrong. If you write 8 times 6, it's wrong. Okay, so it's a very easy problem. We don't need to calculate. We don't need to perform the operation. Just we need to compare between the number of rows and the number of columns and deduce the correct relation. We're going to number 5. Number 5, what is the dimensions of the matrix resulted from the following multiplication process? We have here two matrices, and we need to multiply. So the first step, we get the order of the first and the order of the second to know we can multiply or not. Of course, he gave me the order for the first, the second, the third, the fourth choices, so we can multiply. But we'll just check. We have 1, 2, 3, 4. So I have 4 rows, and I have 1, 2, 3. So 3 columns. Okay, I'm going to get the number of rows here, 1, 2, 3. So I have 3 rows and only one column. So I have here 3 rows and 1 column. We can multiply. Yes, you can multiply. Why? Because the inner numbers are the same. The number of columns, or the column for the first matrix equal to the row for the second matrix. So I can multiply. I can multiply. This is the first step. But what about the product? The product will be by the order. Yes, 4 multiplied by 1. So 4 multiplied by 1. So the means and the extremes. The means denote that we can multiply or not. It means the inner numbers, and the extremes are the order of the product of the two matrices, which are 4 times 1. So 4 times 1 is our answer. So the result of number 5 is letter C. Is letter C. We're going to number 6. In number 6 is the result of multiplication of this multiplication. The result of this multiplication. Mister, we'll do how we can do multiplication. How we can do multiplication. Here, I said with you how to do the multiplication operation, but we can solve it from the first side without multiplication. How, Mister? Get the order of the first. The order of the first, Mister, is 1 row and 3 columns. Okay, the order of the second is 1, 2, 3. So 3 rows and 2 columns. Mister, the inner numbers are the same. So Mister, it's 3 and 3. So I can multiply. Okay, so I can multiply. But what is the product? The product will be 1 times 2. 1 times 2. 1 times 2, it means I have 1 row and 2 columns. 1 row and 2 what? And 2 columns. So 1 row, 1 row, 1 row, 1 row, and 2 columns. 1 row and 2 columns. So the answer will be letter D. Without calculation, without wasting the time, in calculation. If Mister, we have two problems or two answers with the same order, what shall we do? How we can multiply? Let's check how we can multiply. If we have a problem like this, I'm just going to maximize the problem like this and work with me. Maximize the problem and work with me. Work in problem number 6. To solve the problem. We just start by multiplying. We said, Mister, it's what times what? It's 1 times 3. So it's the result will be, or the matrix, the result matrix will be, the result matrix will be 1 times 2. So 1 row and 2 columns. How we can get 1 row and 2 columns? Pay attention with me, please. First, we start with the first row. I'll multiply the first row with the first column. The first row with the first column. First row with the first column to get the first element. Okay. Means, Mister, you multiply 4 by 2. Yes, I just multiply here. 4 multiplied by 2. So 4 multiplied by 2, it's equal to 8. So I just write 8. And then after that, 0 multiplied by -3, Mister, plus 0. And then after that, -2 multiplied by 0 equals 0 also. So I just plus 0. This is the first element. Okay, I'm going to the second element. From where, Mister, you go to the second element? I have the same row. So I'm going to the second column. So from the first column to the second column, it means I'm going here also in the result into the second column. This is the first one, and this is the second column. We're going to get the second column by the same way. How? Start 4 multiplied by -1. It's equal to -4. 0 multiplied by 0. It's equal to 0. So add 0. 4 multiplied by -2. It's -8. Now we get the result. What is the result? The result is 8 plus 0 plus 0. It's equal to 8. And here -4 plus 0 plus -8 equals to 12. So we have here 8 and negative 12 is our answer. So the result will be letter A by using the calculation, but we said we can solve it from the first side or يعني بمجرد النظر لو استخدمنا order method, the order method. Okay, we're going to number 8. What is number 8? The multiplicative inverse for this matrix. The multiplicative inverse for this, sorry, number 7. Number 7, the value of C that makes the matrix doesn't have a multiplicative inverse. We said that. The matrix has no multiplicative inverse. The matrix has no multiplicative inverse if and only if the determinant is equal to 0. The determinant is equal to 0. So its determinant equal to 0. So I get the determinant here and make equality by 0. What is the determinant? The product of main diagonal minus the other diagonal. So the product of the main diagonal elements, Mr., is negative 6 and 4. Negative 6 and 4. Negative 6 times 4 equals negative 24. And then after that, minus from the rule. 3 times C. So Mr. 3C. So negative 24 minus C must equal to 0 because our matrix has no multiplicative inverse. Okay, now solve this equation. Solve this equation. In the other side, by the opposite sign, so Mr. It will be equals to 3C equals negative 24 divided by 3 divided by 3. So C equals to negative 8. So the answer here will be letter D, which is negative 8, which is negative 8. Okay. So again, from the beginning, to get the value of C here, he said that the matrix has no multiplicative inverse. It means its determinant must be equal to 0. I get the determinant and make equality by 0 and solve the equation for C and get the value of C, which is negative 8. We're going to number 8. We're going to the multiplicative inverse of this matrix. What is the multiplicative inverse for this matrix? This matrix has a multiplicative inverse. Let's check. Get the determinant first. To get the determinant, the main diagonal element 6 times 0 equals 0 minus negative 3 times negative 1 equals 3. So I just write here. So the answer will be negative 3. So the answer will be negative 3. So our determinant is negative 3. How we can get the multiplicative inverse? You can get, yes, you can get the multiplicative inverse because your multiplicative, determinant is not equal to 0. Any number except 0. So the rule said that 1 over the determinant. So 1 over negative 3. And then after that, get the cofactor. What is the cofactor? We said that the cofactor is to switch the main diagonal. The main diagonals are 6 and 0. I switch them. It will be 0 and 6. And then after that, you will change the sign of the other diagonal. Change the sign. So it will be here 3 and negative 1 will be a positive 1 here. Okay. Now after that, you will multiply. Multiply, mister. So multiply negative third by the elements inside. So it will be 0. It will be negative 1. It will be negative third. It will be as negative 3. Sorry, negative 2. So the result will be letter B. So letter B is our answer. Letter B is our answer for number 8. We're going to number 9. Number 9, he said we have two matrices which are equal. Two matrices are equal if and only if the corresponding elements are equal. The corresponding elements are equal. I need the value of R and the value of T. Get the corresponding elements respectively. It means with the order. Start by the value of R and then the value of T. Be attention about this, please. We have here 14 must be equal to its corresponding, which is what? Oh, negative 7R. So negative 7R must be equal to 14 divided by negative 7 divided by negative 7. So R equals to negative 2. r equals to -2, I can stop here because I have r equals to -2, only one answer. We need to check. We need to check. So I'm going to -3 with -3. T, oh, 3t, and the corresponding elements for 3t in the other matrix will be, yes, 15. So divide by 3 here and divide by 3 here. So t equals to 5. T equals to 5, and this is the right answer as we get from the first trial. From the first trial. We're going to the next and the last problem with us today. The result of this operation, as you see, I need to add. Before addition, I have to multiply. So, Mister, I need to multiply first. So, multiply first, Mister. I have to multiply 2 by the first matrix. It will be 6. It will be 10. It will be -12. It will be 0. And then after that, plus. We're going to multiply the second. We have here 4 times 9 is 36. So I just write here 36, -4, and 8. And this will be 12, which equal to, add, Mr. 6 plus 36 is equal to 40. So it's equal to, sorry, 42. Sorry, 42. We have to write 42. So 42 from the beginning. So 36 is out. 39 is out. Maybe B and maybe C. I'm going to the last element because they are different here. We have here 0 and we have here 12. So it's determine the answer. We have here 0, 0 plus 12. 0 plus 12 is equal to 12. So 42 and here 12, which is letter C. Mister, I need to complete to be sure that our answer is right. Okay, so 10 plus -4 equals to 6, and -12 plus 8 equals to -4. So the answer will be letter C, as we said from the beginning, and this is our answer. This is our answer, and this is our end of the session for the matrix. In this session, we talk about the matrix and how we can get the meaning of the matrix order, which is the number of rows and the number of columns, how to get the operations on the matrix, adding, subtraction. They must have the same order to add and subtract, and add the corresponding elements or subtract them. How to multiply the matrix, and the condition that must be satisfied to multiply to or to get the product of two matrices. And also we talk about the types of matrix, quality of matrix, how we can get the determinant, how we can use the determinant to get the multiplicative inverse of the matrix. Thanks and see